For section 10.3 part 2, we're going to be looking at maximum area. We're going to be looking at using what we know about polynomials and finding vertices to calculate maximum area. So let's go ahead and look at this word problem. Yes, I want you to write it down word for word. This is the only problem we'll do on this set of notes, but you're going to write it down. A farmer has 120 feet of fencing. So he's got 120 feet of fencing that he needs to use to put a fence around his field next to this building. He wants to know exactly what his width should be on two of the sides to make sure that he maximizes the area of that field. And you can use parabolas, finding the vertex of a parabola, to find the highest or maximum vertex, and the highest vertex to create the maximum area under the curve, which is kind of getting us into a little bit of calculus here. So let's go ahead and look at this. The easiest way to do these is really just to draw a picture. So here's the rectangular field, and here's this building. So it says he wants to fence in this rectangular field next to a building. Well, he doesn't need any fencing along the building because the building is going to provide a border there. So he's really only got 3 sides, but he's got 120 feet total. Now, we know that the top and the bottom have to be the same length. We don't know what length, but we know they need to be the same length. So I'm going to label those both X since we know they're the same. We don't know what they are, but we know they're the same. Now, if he has 120 total, what's left is going to be that 120 minus those 2 x's. So if he had 120 total, take away the x he put here and take away the x he put here, this is what's left, which is what's going to go on this side. So we've got x and 120 minus 2x. Now, since we know we want maximum area, what we're going to do is take the area of a rectangle, which is length times width, and we're actually going to use these dimensions and try to get it into standard form so we can find a vertex. Remember, the whole goal is to find a vertex. So we can find the vertex, we can find the maximum area under the curve. So area is length times width, and in this case, I know both. My length is x, my width is 120 minus 2x, or vice versa. Doesn't matter how you look at it. Multiply that in, you get 120x minus 2x squared. I'm going to write that properly and jump that 2x squared to the front because that's how we're used to seeing it. So my area is negative 2x squared plus 120x. Now, what I need to do is find my vertex. If I can find my vertex, here's what's going to happen. The x-coordinate of my vertex, whatever the x-coordinate of my vertex is going to be my width. That's what I need to use for my x's in here. This y, or this second coordinate, is going to be your maximum area. So if I can find the vertex, I can find everything I need to know. I can find the width, and I can also find the maximum area. So I'm going to go back into this problem, and if you remember how we find vertex from standard form, it's negative b over 2a. So negative b would be negative 120 over 2a, which would be 2 times a negative 2, and I'm going to get a 30. That means I need to make these x's 30 feet. If I take that 30 and actually plug it back into the original standard form, I get 1,800. That is my maximum area. So 1,800 is my max area. 30 happens to be my width. And that's, if I was this farmer, that's how I would want to build this rectangle to maximize my area.